Okay. Same thing we can try to okay, we can try this question. Okay, this one is again water heater. This is the heater, and we have connected this one to commercial power supply. It's 230 volt AC. And wattage of this heater is, this is 1000 watt. Okay. Then we have to find current. Going through this circuit. It's not a difficult question, because you know that W equals VI, then V is 230 volts to I. One question is asked that why, if the frequency is given, but actually that when we, it's a kind of practice that, but actually in here, for this question, this frequency value is not necessary. This one, the question is asked why this frequency value is given. This one. But for the moment, for this question, to work out this question, this one is not necessary. But to indicate that it's a kind of AC voltage, the AC power, normally we are giving the frequency of the AC voltage. It's a practice. But without giving this one also, you can receive a question only having this figure 230 volt AC. That is enough. As a practice, we are giving this one. Normally, that 230 volt, 50 hertz, and maybe 110. Another popular voltage around the world is 110. It's 60 hertz. Okay. Okay. You want to see the question again? This is the question. This is 4.35 amperes. Now we know the voltage and current also, but here we are not going to find the resistance of the heat. Instead of that one, we have different figure. Using this one, we can find the current. Okay. In the next question, if the heater is used for 2 hours per day, find the amount of energy used during in 1 month period. For a 1 month period, we have to calculate how much of energy we have used, but the duration per day is 2 hours. Energy we can find 1000 watt, 2 hours per day, but 30 days per month. Then this watt hours, 60,000 watt hours. Then we can convert this one into kilowatt hours. Then if we divide this 60,000 by 1000, then it will become kilowatt hours. 60 kilowatt hours. Next one, we can convert this 60,000 watt hours into minutes and then seconds. Then the unit is joule. 1, 2, 3. Something wrong? 1000 words, 2 hours per day for 1 month. Then is it okay? Someone of
This is correct, sir.
yeah. Then this is 216 million joules. I don't think that anything difficult here. If you have any difficulties that when you calculate these things, please ask. Shall we go to the next question? Okay, now we have a circuit. 3 resistors have been connected to the one battery. The resistors are connected in series. They have 6, 4, 10 resistances. Now we have to find total resistors of the circuit because we have 3 resistors separately and we have to find the equivalent resistance of the circuit and current going through it and voltage across each resistor and power dissipated by each resistor. Okay, shall we start doing this one? As you mentioned at the very beginning, we are not going to do much more new things, but only the thing that you have to make sure that you can apply those things to find the different values of the circuit. That's what we are going to do. Can you try this? total resistance of the circuit R. It's a series connection in between these resistors, then we can add all the resistors together. 6 ohms, 4 ohms plus 10 ohms. The total resistance of the circuit is 20 ohms. The circuit current I, the current I, that the voltage is 36 volts and resistance is 20 ohms. Okay. This is 1.8 amperes. C. Voltage across each resistor. Okay. If you take this one, this is VR1, and across this one, if it is VR2, and across this one, if it is VR3. Okay. And the current for all these resistors are common. Then we can find VR1 is I 1.8 ampere, resistance 6 ohms. This is 10.8 volts. VR2, again the same current is going through resistor 2 also. Then resistance value 4 ohms. And it's 72 volts. Sorry, 7.2 volts. And VR3 1.8 ampere. The resistance is 10 ohms. It's 10 ohms. Then 18 volts. This is 10.8, 7.2, 18. Altogether, it should be 36 volts. Because this 36 volt is divided among these three resistors because they are in series. Then when you add this 10.8, 7.2, and 18 together, it should be 336 volts. power dissipated by each resistor. Power dissipated by each resistor. D wattage R1, you can find I into VR1, I 1.8 ampere, VR1 10.8 volts. It's 19.44 watts. Then this wattage, we have got 2, the same current again going through it. Then voltage is 7.2 volts. It's 12.96 voltage. Then voltage of resistor 3, same current, and 18 volts. This is 32.4 watts. Yes, this can't we apply W equals I squared R to find the voltage? Yes, we can do to find the voltage. I think the question is asked that because the W equals VI, but you know that V equals IR, you can replace this V by IR, then IRI, then this is I squared R. To find voltage, you can use this I squared OR. Then here, if you want, you can substitute I also. Then V is there. What is I? V divided by R. And this is V squared divided by R. So one of these equation you can use to find voltage. Then the power delivered to the circuit by the voltage source. Okay. then we can find the power delivered by voltage source to the circuit. Then voltage source is 36 volts and current is 1.8 ampere. And this is 64.8 watt. And when you add all these three figures together, what is this? This is the power dissipated by R1. This is power dissipation of R2. This is power dissipation of R3. When you add all these three things together, then what is that? Again, this is 64.8 watt. You can see this one and this one. It's two identical figures. This is what last part of question is asked. Verify that the power delivered dissipated by the resistors is equal to the power delivered to the circuit by the voltage source. That's it. Okay. Actually, that we have to practice these type of questions today completely, because next day we are going to discuss a new theorem. Because of that, today we shall finish these questions. Okay. Now, shall we try this one? We have a DC power supply. How do I say DC volt? It's 12 volts, 2 ampere. It's not mentioned it's as AC. Then there are four different sub-circuits. First one is pre-amplifier, LCD, power amplifier, and couple of indicators. Okay. We have to provide power for all these four circuits, but when you connect all these circuits to the main power source, the currents drawn by each and every circuit, they have those figures are given. Then we have to find the total current of the circuit and the reserve current available. Shall we try this? This question says us there is a power supply. Power supply. From this power supply line, the positive terminal is there and 0 volts terminal is there. And we have four different circuits. sub-circuit. First one is preamplifier, preamp. Second one LCD. Third one power amplifier, and some LEDs. Okay. Then we have given power to this one, taking this line here and we have taken power to this line and this sub-circuit, and the other one also. Okay. Then this line like this. Then for the preamplifier, 60 milliampere current is going on, and this 15 milliamperes for LCD display. 1.5 amperes for power amplifier and 35 milliamperes for the indicators. Okay. Actually, that here, what is the theorem we are going to use? Actually, we are going to use Kirchhoff current law. Okay. It says us when you consider one node, there may be a couple of branches in a circuit. Okay. All these currents going out like this. Algebraic sum of total incoming currents are equal to algebraic sum of total outgoing currents. For example, here I4 plus I5 plus I6 is equal to I1 plus I2 plus I3. Okay. In other words, I4 plus I5 plus I6 minus I1 minus I2 minus I3 equals to 0. Okay, then here to find total current, you can add 60 milliampere, 15 milliampere. This 1.5 ampere actually it's 1500 milliamperes. and 35 milliamperes. You can add all current, four currents together. Then if you put this one in milliamperes, then it's 75, 80, 110, it's 610. Or you can say it's 1.61 amperes. Yes, this is Kirchhoff law. Actually, this is Kirchhoff current law. Kirchhoff has introduced the two laws, Kirchhoff current law and Kirchhoff voltage law. So this is Kirchhoff current law. Okay, sorry. This is not 1500, this is 1200. Then its total figure should be changed. It's 1310. Okay. Then what is the reserve current of the circuit? Power supply. Then it's having the capability to deliver 2 amperes. But now we have taken only 1.31 amperes. Then reserve current. 2 amperes minus 1.31. Is it okay?
Excuse me, sir.
Yes.
The circuits are, the devices are connected in parallel, right?
Yes. Yeah.
If not, okay, sir. Thank you, sir.
Okay. If it is okay, Then shall we move to the next question? We have power supply. It's connected to the that kind of circuit, and there are two different circuit blocks. Through this one, 50 milliampere current is going to this block. We don't know what is inside this block, but anyway, the 50 milliampere current is going to this B block, and here 10 milliampere current is going to this block. There may be certain circuit blocks, we don't know what is inside here. And here also another circuit block. As a result of this connection, these are the currents going on to this one. And we have to find the value of this resistor. Okay. You can try to find this current, but there, this current and this current this is the uh, Zener diode current. It also given. Then you have to find the resistor value. This current is 10 milliampere, this current is 10 milliampere, then across this resistor, 20 milliampere current is going through. Okay. Then what is the voltage of this one? It's 10 volts. But when you consider this part, the voltage of this part is 4.7 volts. Then what is the voltage across this resistor? The balance of this one. Here 10 volts is applied to these two nodes. Then across these two components, 10 volt is applied. Then across Zener diode, we have 4.7 volts. Then balance voltage should be here. It's 5.3 volts. And 5.3 volt is the voltage across the resistor, and the current going through the resistor is 20 milliampere. Then you can find easily R divided 5.3 volts divided by 20 milliampere. Okay. It's 265 ohms. Then how did current become 20 ohms? Sorry, 20. Because that's the Zener, through the Zener diode, the Zener current is 10 milliampere. And it's mentioned that towards the subcircuit A, the 10 milliampere current is going this direction. Then when you consider this node, this current and this Zener current and the circuit A current is going away from this node, then the incoming current of this node should be addition of these two currents, then 10 milliampere, 10 milliampere, and this should be 20 milliampere. This is the incoming current, and this is the outgoing current, and this is outgoing current. Then these two should be equal to the total incoming current. Okay, shall we try this? And this is very easy one. And the previous question, it is asked to explain it again. Here, then we want to find this resistance. We want to find this one. Okay. Then to find this one, we want to find the voltage across this one and current going through it. The voltage is either easy to find because the applied voltage is 10 volts here. And it has been divided into two. Across the center, we have 4.7 volts. Then definitely across R, it should be 5.3 volts. Because addition of these two should be equal to 10 volts. Then when you consider current, this is the outgoing current from this node, and this is the other outgoing current from these nodes, away from the node. And total incoming current to this node is 20 milliampere. Then this 20 milliampere, 10 milliampere element should be equal to this one. Then the current going through the resistor is 20 milliampere. Then we know the voltage. Okay. We know the voltage, it's 5.3 volts. And we know the current is 20 milliampere. And this is the current. Okay. Then if you're okay with that, and this is another very simple question. And again, you have to use Kirchhoff current law. You can see that outgoing current from this node is 10 ampere. Okay. Then one current is coming this way, it's 2 ampere. Then this is 3 ampere. Because of that, this 2 ampere plus 3 ampere is 5 amperes. And then this should be 5 ampere. That's why we can make 10 ampere. And 5 plus 3, 8 plus 2, 10. Then these currents are okay. And what about this current? This is the outgoing current, incoming current, because that this is definitely it's 10 ampere. Okay. When you consider this incoming current of this node and these outgoing three currents, they should be identical. And if this current is 10 ampere, this is 3 ampere current is coming from this side, then definitely this should be 7 amperes. Okay, shall we try this one? You can consider this node 24 ampere current in and through this resistor 11 ampere current is going away. Then this should be definitely okay. Should be 7 amperes. Sorry, not 7 amperes. It's 13 amperes. 13 amperes. And when you consider this node, 13 ampere current is coming to this one. This is 6 ampere going away. Then definitely this should be 7 amperes. This direction. Okay. If this is 7 and if this is 11, 11 plus 7, this is how much? This is 11 plus 7, 18. But all the current 7 ampere, 11 ampere, then here is 18 amperes, but 6 ampere current is coming from this side, then 24, and totally outgoing current, it should be 24 amperes like this. Okay, can you try this one here? This current is it's 0 ampere. Then from this side, it's 500 microampere current is coming in towards the inside of this device, this amplifier. It does not take current. Then all current should go this direction. Okay. Take a couple of minutes and try this. this node, this 500 microampere current is coming in, then there is no way to go this side, then definitely this current is 500 microampere, it's I2 current. Okay, then from here it's 500 microampere coming down, then another 200 microampere current is coming from the downside. Then this I4 should be 500 plus 200 microampere current, should be 700 microampere current. But see the direction, we have marked this way. Because of that, the direction should be minus. Okay, now shall we try a little bit different question, but not the things that we have to find, but anyway that it appears a different question. The 11th question, is it okay? 11th question. Because you are asked to show the 11th question again. Is it okay? Okay, then this is 12th question. 12th question, actually, this is very easy because you have to consider this current. This current has to go this way, but here is 0 ampere current is mentioned here. We don't know some other, because of some reason, the current going inside this device is 0. Then this current should go to this resistor. It's 500 microampere. Then it's coming down towards this node. It's 500 microampere. And at the same time, this I3 current is coming upward. Then when you consider this node, this top and bottom two currents getting added to a single current, then it should go this way. The current should go this way. But we marked this one differently. That's why we put minus here. Okay. Now we can try this different question. Now we have three resistors there. Okay, how can we find the answers for this one? We have to find equivalent resistance of the circuit. Okay, here equivalent resistance of this circuit is R EQ is R1 plus R2 R3 parallel. Okay. Then resistance from this part is 10 to 40, 10 plus 40, then it's 400 divided by 50. Then it's 8. Let's see. 8 kilo ohm. Then here is R1 is 12K and this is 8K. The total equivalent resistance is 20K. Okay. Then determine I1 and I2 and I3. I1 is this. I2 is current going through R2. I3 is current going through R. I1, we can easily find I1 because there is a current coming from the battery directly. Can you hear me?
Yes, sir.
We can find I3 easily. Sorry, I1. I1 is 48 volts divided by 20K. Battery voltage is 48. Yes, 48 volts divided by 20K. Then this is 2.4 milliamperes. Okay. Then total current coming towards this one is 2.4 milliamperes. Then here you can use actually determine I1 and I2, I3. And to determine that one, you can use that voltage current, the current dividing rule here. Then to determine I2, we can find I2, I1 times this R3 resistor, I1 times R3, R2 plus R. Using this equation, we can solve this. This I1 means 2.4 milliamperes. R3, R3 40K, 10K, 40K, 10K plus 40K. Then it's 2.4 into 40 divided by 50 milliamperes. It's 1.92 milliamperes. Likewise, we can find I3. I3 is again I1 times R2, then R2 plus R3. I1 is 2.4 milliampere, R2 is 10K, this is 10K plus 40K. It's 2.4 into 10, this is 50K. It's 0.48 milliamperes. Okay. Then to find voltages, calculate V1 and V2. V1 is the voltage across this part, V2 is voltage across this. To find this one, we can apply this voltage dividing rule, because this voltage is V1 and across these two resistors we have V2, and if we consider this voltage V, this V1 equals to V times this one 12K, when the equivalent resistance of this part is 8K, then this is 8K. Okay. Then V is 48 volts into 12, then this is 20 ohms, 20 kilo ohms. Okay, then this is 28.8 volts. V2, this one equals to V times, this is here, this is 8K, this 12K plus 8K. This is V is 48 volts into 8, and this is 20. 19.2 volts. Like that. But here we have applied voltage dividing rule. This is voltage dividing rule. And here we apply current dividing rule. Okay. When you have a circuit like this, okay, actually there are many ways to find these currents and voltages, and you can find the different way and different equations, and you can write simultaneous equations also to find this one. But this is the easiest way to do this one. You can directly apply this voltage dividing rule and current dividing rule to find the answers of this question. Okay. Then actually we have to discuss a couple of questions more, but next day at the beginning we can discuss those things, and after that the second half of the next day we can discuss a new theorem to find the solution, to find the different values of these circuits. Okay. Do you have any question? Anything? Any question? If you have any question that we can find, if not, we can finish the session today. And thank you very much for joining here, and take care of yourself and be safe. Thank you very much.
Thank you, sir.
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 Thank you, sir.